Single phase induction motors has no connection, no electrical connection between the rotor and the supply. Now, the way that it operates is the motor has two sets of coils. The first set is the running coil. The running coil is connected to the supply between live and neutral, and they will experience a sine wave in voltage. That will result in the polarity and the strength of the magnetic field generated to constantly change. Increase in a north pole, increase in a south pole, and then as the voltage decreases, the strength decreases, and once we go into the negative half cycle, then the polarity swaps and increases in that direction. The second coil is my starting coil. It works exactly the same. It experiences a sine wave, and as a result it has magnetic field. It's constantly changing, increasing in strength and swapping in polarity depending on the cycle. Now, because these are two different coils and they are connected to the same supply, the voltage applied to both of those coils is exactly the same. However, the current that flows through those coils, because of the difference in inductance of the coils, number one, and secondly, because of the difference in the resistance of those coils, they will have a phase shifting ability on the current that those two coils experience. If you think back to RLC circuits, when looking at a coil, we know that the voltage on the coil will be vertical. The resistance will be horizontal. Now, this resistance that we talk of over here is the internal resistance of the coil. So the result is that for the coil, if the supply voltage is applied, then the voltage will generate an inductive and resistive effect, and the result will be that there will be a current flow for the running coil at a specific angle. But I have to remember that this same voltage is applied to my starting coil. The result being that for my starting coil, if it has different resistance and different reactance, then its effect is going to be, let's say it's closer to being purely inductive. That means that the current that it's going to allow through will have, I'm just going to extend that line a bit, the current that it'll have will have a phase angle of, looks like about 30 degrees. Now, in order to improve the ability of the split phase motor, we need to increase this phase angle generated between the current on the start and the current through the running coil. We do that by means of a capacitor, but we'll go into more detail regarding that. When looking at the effect that these magnetic fields, these currents have we will see that there will be a constantly changing magnetic field on my starting coil, as well as a constantly changing magnetic field on my running coil. We've discussed how that is going to cause the magnetic field to seem to rotate in the coil. Now, looking at the rotor is made up of conductive rods, and as this changing magnetic field cuts through those rods, these individual rods are going to create a current within themselves, which in turn is going to generate a magnetic field around those conductive rods. Because of those magnetic fields and the magnetic fields created by the stator windings, we are going to get a reaction between the stator magnetic fields and the rotor's magnetic fields, and that is going to cause the rotor to rotate.